Hello, Uche. Kekwan. Good morning. How you doing? I hope you are fine. Okay, so welcome to our class. I hope it's a beautiful morning out there. I think it's sunny out. It's not going to rain today. I hope so. So we thank Jehovah that we are having a very beautiful day. At least it's also beautiful that we are going to use it to learn today. So today we are going to look at something as a continuation of the previous class on arithmetic progression. How did you find that discussion? I hope it's very fine. So today we are going to look at a continuation of the arithmetic progression, and what we have today is general form of an arithmetic progression. General form of an arithmetic progression. So it is called general form because it is possible that you might have different progressions given to you. So what is that general formula that you can use to solve any of them? So in the process of our class, we are going to identify how to use a formula to find the general form of an arithmetic progression. We're also going to look at the process of finding the first term, the common difference, and of course the last time we did nth term of an arithmetic progression and how to confirm whether a progression is arithmetic or not. I hope you enjoyed that class. So today we are going to look at a particular formula. This formula is going to be the same all over. So as long as you know how to use the formula, then any question that you see, you could actually use it to solve whatever problem that you have. So the general form of an arithmetic progression comes in this format. So let's look at the format that it appears in. So this is the format. So this is A plus D, A plus 2D, A plus 3D, A plus 4D, A plus 5D, and so on. Okay. Alright, so that is what you have. A plus D, A plus 2D. Please let me even try to advise that if for any reason you're not seeing what you are, what is being written, because I've noticed that each time I use a black marker you see clearly, but if I use any other color of marker, especially green or red, it becomes difficult to see. Please, if for any reason you're not seeing, try to wipe your camera or your screen a little so that you can see what is being taught. Alright, so now this is the general form of an arithmetic progression. Now notice that there were things introduced, A and D. In the previous class we noticed that D stood for common difference and it still stands for that, but A here stands for first term. So A is your first term, while D is your common difference. And we have explained that common difference is the difference between two of the numbers in a progression. Okay? And it's common throughout, meaning you use it throughout the progression. So if A is the first term, alright, if A is the first term and D is the common difference of an, so if A is the first term and D is the common difference of an arithmetic progression, then its nth term. So for you to find the nth term is A plus n minus 1 D, A plus bracket n minus 1 D. Okay, so if you have an arithmetic progression and you're asked to find the first term or the common difference, the nth term, that is nth term, I've already explained what this nth term means. Nth term means they say find the 15th term, find the 16th term when some progressions are. So this nth, it is called nth, is a cardinal point. Nth term, first, second, third, fourth, fifth, sixth, any of them you are asked to find. This is the formula to use to find them. Okay. So that's it. So using the definition above, okay, using that particular definition above, it means therefore that if you have a2 minus a1 will give you the common difference. Okay, so if I have 1, 2, 3, 4, 5 like that, so a2, which is the first term, this second term minus the first term will give you the common difference. So 2 minus 1 is 1, 3 minus 2 is 1, which is a common difference. Okay, so that's what we are having. All right, so now what that also means is that it also means that a2 is equal to, if this moves over, so you are going to have a1 plus d will give you a2, right? A1 plus d will give you a2. So in that same way, you have it that a2 is equal to, so a plus d. So if you add the first term, and the common difference, you will get a2. Okay, so it also implies that a2 is equal to 2 minus 1 a plus d. Okay, 2 minus 1 a plus d. That is, if whatever you have is 2, then the first number is 1. So if you subtract both of them together, you are getting what you have down there. All right. So now remember that a2 means the second term. Okay, but this is like a general formula for it. Depending on what you are given to do. All right, so that's what you have. So please, if not for anything, you are required to ensure that this formula stays with you to find the nth term of an arithmetic progression. All right. Now, what if you want to find the nth term of an arithmetic progression from the back, from the end? Let's say you are given a fixed number of or a set of values. What if you want to find the arithmetic progression or the nth term of an AP from the end? So let's say you have, let A and D. Remember, A is your first term and D is a common difference. Let them be the first. Let them be the first term and common difference. Keep my own. Of an AP. Having m number of terms. So when you say m terms, meaning that the terms are known. You know the first term, you know the last term, because what we're looking at is from the end. For instance, you have 1 to 10. The first term is 1. The last term is 10, right? And the values you're having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The common difference in numbers like that from 1 to 10 is 1. Their last digit is 10. Their first term is 1, right? So in that vein, what do we do? So then the nth term from the end is given as m minus n plus 1. Please look at that. M minus n plus, so that is that m, the total number, minus n plus 1, nth term from the beginning. Okay, therefore the nth term of the end is equal to a, which is the first term, m minus n plus 1, which is equal to a plus m minus n plus 1 minus 1d, which will give you a plus m minus 1, minus n d. All right, so this is, so if you are finding n term of an arithmetic progression from the end, you use a plus the total number minus n, then the common difference. Okay, so that is the way, that is if you are finding it from the end, a plus m minus n d. This is a standard formula that you need to get in your head. All right, okay, all right, so let's see another method of, there's one thing about this formula. It's one thing to know them, and it's another to know how to use them. So as much as you are paying attention to how they are gotten, you also should know how it is gotten. So method 2, to find the general form of an arithmetic progression, that is for that same one that we have. You have a plus d, then a plus 2d, like that. So to find the second term, you have a plus d, right? To find the second term, just like you have 1, 2, 3, 4, 5, the second term is 2. To find this 2, you say a, which is 1, plus common difference, which is 1. So a plus d will give you, please let me clean the 1, 2, 3. I'm using 1, 2, 3 because it's an arithmetic progression. So a plus d will give you a plus 2 minus 1d, right? A plus 2 minus 1d. Now it is 2. Remember, it's a plus n minus 1d. N stands for 2. We are looking for the second term. This is your second term, which is what we are looking for. So if they say find the 15th term, that n here, substitute as what? 15. So that's what we have. So in general, whatever you are having, you are going to have. So in let's say 1 2 3 4 5, continue. So the first term is what? 1. Okay, 1 plus 2 minus 1, common difference is 1. So which is 1 plus 1 times 1, which will give you 2. Okay, 2 minus 1 is 1, times this one is 1. So 1 plus this one will give you 2. Okay, that's how it is gotten. Alright, so let's look at some solved examples. Let's look at some solved examples that we can use. You can pause, but I want to clean now. So I also advise, since you are using your YouTube to watch, when it gets to the point where you don't understand, you can pause and play back. It will help to clarify certain things. Number 1, let's look at some examples. Here it says, show that the sequence 3 5 7 9 11 is an arithmetic progression. Then find its 15th term and the general term. So find its 15th term and the general term. Alright, so let's see what we have. So nth term is equal to a plus n minus 1d, where a is what? The first term, and the first term is 3, right? N is 15. Okay, okay, yes, before we even start finding the 15th term, they say you should show that the sequence is an AP. So let's do that. Now the first term, I'm going to write my solution here. Let's show that it's an AP. The first term of the sequence is 3. The second term is 5. The third term, so I'm taking it maybe with English, because then and so on. Now, second term minus first term give us 2, right? Notice again that third term minus, so third minus second also give us 2. Now notice that all of them, if you second minus first 2, third minus second 2, fourth minus third 2. So therefore, since common difference, since d is equal to 2 for all values, the sequence is an arithmetic progression. Do you understand? So since everything we do, if you check 5 minus 3, 2, 7 minus 5, 2. Excuse me, I think there's a mistake here. 9 minus 7, 2. 11 minus 9, 2. So since all of them, their common differences are giving us 2, then it is an arithmetic progression. Alright? So that answers the first part. Now let's go to the second part. Let's go to the second part. Let's go to the second part. So the second part, I say find its 15th term. So to find 15th term using general form, which is a plus n minus 1d. Therefore, a, the first term there, according to what we have, a is what? A is 3. What is d? Common difference is 2, which is equal to, maybe use any one, 5 minus 3. Then your nth n is 15. So if we substitute, so substituting, we have a, like we said, is 3 plus n is 15 minus 1, and d is what? 2. So clear the bracket. We have 3 plus 14 times 2. So 14 times 2 is 28. So 3 plus 28, we're having 31. Therefore, the 15th term is what? 31. The 15th term is what? Is 31. So you see that it's very easy to solve, especially when you are getting the nth term. It's very easy to solve. Alright? Once this formula is known to you, you can find any, even if it's 1 millionth term, you can find it. Alright? Okay, so now let me give you 2 questions, just 2, for you to practice with. Then I'm going to solve questions that you sent me. Alright? Because I want us to finish discussion on this arithmetic progression before eventually we would go over to another topic, because it's a topic I've not really taught you before until now. So to do, so number 1, which term of the sequence 6, 11, 16, 21, 26, is 1, 2, 6. So that's 1. Number 2, find the 18th term. Find the 18th term. Sorry. Let's not use 18th. Or find the 18th term. Of the arithmetic find the 18th term of the arithmetic progression. You have 31, 25, 19, 13, and that. Okay, so these are the 2 that you are supposed to solve yourself. All right, let me see how fast your brain can work. Okay, let's see how fast your brain can work. But please, another thing you can do is this. You can look at, you can flip through your WAEC past questions and check to find questions on AP, or finding the nth term of an AP, and it will show how zealous you are to understand this topic. Okay, all right. So, but for now, the ones I've given to you are these two. So all you need to do is to solve for whatever you have, all right, in your past questions, including this one. Okay, so now let's revisit our past questions. Now let's revisit questions from past paper. So I'm seeing one here that says convert the speed 90 kilometers per hour. Convert the speed 90 kilometers per hour of a car to meters per second. So they are taking you to physics. Convert the speed 90 kilometers per hour of a car to meters per second, right? So let's see how that can be done. Well, now look at this. There's something that is called standard system of units, or what in physics you refer to as SI units. Now don't think too far. What this means is that there is no value for anything that does not have a unit attached to it. For instance, you go to a market and you want to buy something. Let's say you want to buy rice. Now, if you want to buy a bag of rice is 50 kg everywhere in the country. So it's a general unit. You say 50 kg of rice, which is one bag of rice. Your mom says, go and buy me one bag of rice. You go there, no matter the brand of rice that you see, it is still the same rice. It's still the same 50 kilograms. That kilograms happens to be a standard unit everywhere in the world. You carry that 50 kg bag, go to China, measure it still gives you 50 kg. You take it to Canada, it still gives you 50 kg. So that's why it's called standard system of units, right? So now if in a car you have that the speed is 90 kilometers per hour, 90 kilometers per hour, we're asked to convert to meters per second. Meters per second. So let's look at what we have. So this is just in your basic mathematics. Since this is not physics, it's just mathematics, you are going to employ what is called proportions to this, right? You are converting a ratio of 90 kilometers per hour to meters per second. So notice that you have kilometer and you have meter. Here you have hour and you have second. Now look at this. Each of them have standard units. Each of them has standard units. So standard unit, hour to second. Standard unit hour to second is equal to, you say, yes, so we need to calculate, yeah? Now 60 seconds makes 1 minute, right? 60 seconds makes 1 minute, right? And then we say 60 minutes is equal to 1 hour. Now they are not saying minutes to hour or seconds to minutes. They are saying what? Seconds to hour, right? So all you need to do is convert whatever you have. You have to convert. First of all, let's convert 60 seconds, right? Let's convert seconds straight to hour. So let's convert seconds straight to hour, and what we have is just 1 hour. So we need to convert seconds to 1 hour. Seconds to 1 hour. So how do we do that? So if 1 hour is 60 minutes, we need to now convert these 60 minutes to seconds. Okay, let's convert 60 minutes to seconds. So converting 60 minutes to seconds. So if 60 seconds makes what? So if 60 seconds is equal to 1 minute, then what will 60 minutes give you? X seconds. So we don't know it, right? So what do we need to do? We cross multiply. Okay, so notice that to find the second, we need to multiply 60 by 60, right? So if we multiply, so x, therefore x will give us, according to cross multiplication, x is going to give us 60 times 60, and that will give us 3,600. So we have 3,600 seconds. Right? So 1 hour is 3,600 seconds. So I want to clean, but you can pause by yourself, right? So 1 hour is 3,600 seconds. So 1 hour is 3,600 seconds. Right? So we have converted hour to seconds. Now let's standard unit. The next one, standard unit. Kilometer to meter. Standard unit, kilometer to meter. Standard unit, kilometer to meter. So we have that 1,000 meters makes 1 kilometer. But what we are looking for is 90 kilometers. So 90 km x meters. Now notice that the one I'm looking for, I'm adding x to it. So if we cross multiply, we're going to have that 90 is going to multiply. We're looking for meters. So 90 will multiply 1,000, which is 90,000, right? So x meters will give you 90 times 1,000, which is 90,000 meters. Alright? 90,000 meters. So 90,000 meters, 3,600 seconds. Alright? 90,000. So what we have, I need you to copy this, but first of all, let's review that in case it confuses you. They want us to convert 90 km per hour to meters per second. So you convert 90 km to meter, separate. Convert seconds or hour. Per hour means 1 hour. Per hour to seconds. So that per hour to seconds is 3,600 seconds. 90 kilometers to meters is 90,000 meters. So all we now need to do, since they say 90 km per hour, we need to now measure this. Okay? So our final answer is 90,000 meters, then 3,600 seconds. Now look at this. If we put it down like this, it's not bad, but we can still convert this to standard form. So let's convert it to standard form. Let's convert this, our final answer, to standard form. Let's convert it to standard form. So if we convert to standard form, we're going to have, okay, so if you convert 90,000 meters to standard form, you are going to have 9 times 10 raised to power 4 meters, then 3.6 times 10 raised to power times 10 raised to power 3 in standard form. But the solution we have, they say we should just get it as a whole number. Now when you say meters per second, meters per second is like saying meters over second. You understand? Or you say ms minus 1. Ms minus 1. It is the same thing as saying m times 1 over s, which is m times s raised to power 1 according to indices. So if that is the case, if we substitute m, the value of m we have was 90,000 meters, right? So we have 90,000 meters. Yes, 90,000 meters over 3,600 seconds. So let's cancel the zeros we have. 36 into 900 will give you 25. So our answer is 25 ms raised to power minus 1. M standing for meters, s for seconds, then your power minus 1. Did you see that? So the brainer is just for you to convert, know the standard of conversions. So what you learned in your basic level, 60 seconds makes 1 minute, is very important here. This is where you apply it. So by the time you apply it that way, you discover that you have already converted. So the car's motion, 90 kilometers per hour, when you convert it to meters per second, it is 25 meters per second. So that's what we have. Okay, it's as simple as that. So if you don't know how to check your standard system of units for length, you better go learn it now, because it's very important. Because questions can appear in this, especially when it comes to theory, where your bulk of marks are found. Okay, so that is that. So let me give you just one that you can do. Let me just give you one that you can practice with. So number 2, you have convert the speed 150 kilometers per hour of a car to meters per second. Number 3, convert the speed 250 kilometers per hour to meters per second. So for each of them, you are required to show all workings, right? So when you show all workings, it proves that you actually know what you are doing. By tomorrow, we are going to look at this question here. It says, Lena bought 400 Alpha Company shares at 1 naira 50 kobo each and sold them at 2 naira 05 kobo each. What was our gain? So we'll look at how to get profit and loss, and also profit and loss percent when we meet again. All right, so it's been a good day, and I hope we've had close to 40 minutes of the class. So all you need to do is get back to your books and ensure that you do your homework, and if you have any questions, ensure you send it to me, or just a call will be very nice, so that we can send you feedback about how these things can be done smoothly. So I wish you a good day, and enjoy yourself, and don't get lazy, work very hard. By next week, the lockdown is supposed to ease off, and we hope that we'll get back to our normal lives. In the meantime, stay safe, stay strong. Cheers.